When you draw in Rhino, you always see these options. I can click on some of them, change them, and continue to change others until I'm satisfied. This is very useful. I do not use it that much in programming. I use dialogues mostly, which we will cover in the next video. But if you want to use this, I will show you how. If you Google Rhino Developer, you can find this site, and then you will find the knowledge base, the examples. You will find many methods that will help you understand different functions and classes and apply some of them. The very first one shows you how to employ command line options. So all I will do in this video is go through this example with you. We will be basically copying the example line by line, but I will try to explain to you what these lines mean so you can comprehend the essence and be able to create your own command line options. So we will just create a new command called I have options, just to be witty. I have options. Great. The important thing to remember is that if you go to your SDK help file and check the get base class that covers the classes, all classes used to get something, you can scroll down and see all these add option methods. Those are the options that we're about to use. Now I will use the get object class. You see that the get base class has many inherited from it, and I will use the get object one, but you have to remember that you can use get number, get point of any of these get base derived classes. So in our new command, let us start by doing something that we already saw before. Let us start by defining an object of the class get object. Of course, we will need a couple of namespaces. Okay, so let us start by creating a new object of the class get object. We'll just set some command prompt that will say select objects. That's enough, and let's set a geometry filter to, let's say, doc objects, object type. Any type is something, any object is something that you can set if you want to, for the user to be able to select any object. And now what we will do, we will set up different types of options. The user will be able to choose some integer value, some double value, a boolean value, a color value. You'll see first we have to set up the options, and then we need the Rhino input custom namespace for that. We have it here. So there is an option integer class. So let's create an object called int option, a new one. And we will use the constructor that tells us what's the initial value, let's say 1, what's the lower limit for our value 1, and what's the upper limit. So the user will be able to choose a number, an integer number between 1 and 99, and the initial default value will be 1. We will kind of do the same with the double number. Let's give it some initial value, some minimum value, and some upper limit. And now, for example, we will have a boolean value, and that will be the class option toggle. We will set the default value to true, and we will set some string pair that will be shown on the line as a toggle, as you will see. And an interesting thing is you can have a list of different values. In our case, an array of strings. Let's call it list values, and you will see in a moment how these are represented. And we will create a list that consists out of 5 names. An array consists out of 5 names. We can immediately define here Let's put some completely random names here. Bran, Rob, Arya, Sansa, Recon. That's it. Couple of names that just came to me. Now that we have all these options, we have to somehow bind them to this getObject class, or to say to this GC object of our getObject class. So this is how we will do it. We will call the method addOption as I shown you before, except that there is an addOption integer specialized to give an integer option. We will give it some name, and we will pass our int option by reference, so it can be changed inside. That's important because we want to update the value every time the user changes it. The name is of course arbitrary. You can set whatever you want and it will appear in your command line. We can do the same thing for a double. We'll just call it double here and reference our double option object. For our toggle, we will add an option toggle. It always fits together. We will call it Boolean. You can call it however you want. And our list here, we will give it some default value. We will call it list index. And let's say our default value is 3. Remember that all lists in all programming, all arrays are 0 based, which means that our default value will be Sansa. And then we will call our addOption list. Where is it? It's here. We will give it some name. We will give it our list of values that we predefined, and we will pass this list index that we just created, which will hold the default value. If we hover over it, we will see that it returns an integer. Let's save this integer here, and it's nothing else than a current chosen value. You will see at the moment how this all works. I cannot demonstrate it right now because we have to finish the command first. Now, in order to be able to repeatedly change options, we have to enter an infinite loop. You can check the while loop in my basic lessons, but here is how a standard infinite while loop looks like. We pass it through all the time so that we never get out of it. And now we can call our selection tool inside. So we will want some get result to hold the results of the get multiple in the same way that we used before for many other selections. Of course, we can check if the user selected something, because we do not want to do anything if they didn't. In the standard way, our command result has to be something, so not if it's not equal to result success, then we will simply return whatever it returns. So now we will simply check what the user did. The user kind of has two main options. First option is that the user actually selected an object, and luckily I wrote result here. What I wanted to write is RC, or let's call this res as a result so that it makes more sense. So this variable here can recognize if the user selected an object or not. You can go to this enumeration again if you want and see what options you have. If you remember, there's lots of options. So we can recognize if the user selected an object and press enter, or if the user actually pressed on one of the options. We can recognize that as well. So you'll get the result, and the result type could actually be an option. So I use the curly brackets here. Sorry for making these mistakes as I type. You will do them all the time. That's the part of the deal. And let's just put the word break for now, because at some point we want to get outside of this loop. Let's first deal with the option when the user wants to change one of the options. So if we are here, this is what we want to do. Let me write it down and then I will explain in a second. So we will access our option index. We will check if it's the same as the option list. Index, it's this variable here. So now I'm just dealing with the list, but as I said, I will explain in a minute. If this is true, list index will be updated. We will access the option and ask for the current list index. So what happened here? This particular part of the code is related only to this list of ours, list of names. The integer and double and boolean options work without any additional code. So this is enough for these three options to work, as you will see. But for the list, you have to add something. Our getObject class has an option index method, as you will see here. This will return the option that is currently selected by the user. If we realize he clicked on the name list, and we know that because you can see we saved the index number of our name list upstairs. So in our list, in the command line, each of our options will have an index number, and this one will have one as well. Once we click on it, it will return its position. If the user clicks on one of the options, we can see on which option they clicked by comparing this option index. If it is our list option, then in that case we will just have to update our list index value. At the beginning it was by default 3, it held the name of Sansa, but once it's changed by the user, it might hold the value of 0, 1, 2, 3 or 4 if the user simply selects a different name. So let's test the command to show you what I mean. So if I write X, I have options, you will see that I have these options that we talked about. If I press on integer, the user will be able to set a new integer and you will see its value here. If I press a double, the user will be able to set a new double, and for the boolean, you can toggle it between on and off. And if we press this option, our list that has the current value of Sansa, if we press that option, our code will recognize its index, compare it here, and then update the list index to whatever option we chose. So if we choose recon, now our list will hold recon. That means that this list index in this case will be updated to the value of 4. I hope you understand what this means. If not, pause the video, look at the code a little bit, think about it. It's pretty intuitive. And the continue keyword, of course, is there so that it skips all the code here and puts us right back at the beginning of the loop. So as long as you're selecting one of these things, you're continuing the loop and you're never getting to this break. That break will be called only if the user actually selects an object. Then whatever is here will be executed, this part will be skipped, and we'll get to break and get out of the loop. So let us execute something when the user selects at least one object. Let's stop the debugging. So if the user selects something and, as I said, at least one object and presses enter, we can write something. So in order for you not to watch me write, I will skip right to the point where I've written the lines and I will explain them to you. Here they are. So what I did here is I just wrote single lines where I wrote the values of our current options. So although you saw that you can see them in the command line, I want to show you that they are actually saved inside these variables here. And you can see once we call those variables, and we access their current value property, we will get their current value. And in our list, we just need to pass our current list index and we will get its value. So let's test this one. In this example, we will not do anything with objects that we selected. We will only print out these options, but the point is that you can very easily use all of the options that you use to do something with the objects. All these options, as you saw, have current value property, and here you can see that the updating of the list index was very important because that is how we access the current value. And if you have some objects in your scene and you start your I have options, you can change this however much you want because you're in an infinite loop. You can change it to whatever value you want. Let's put this to brand, and then once the user selects the object and presses enter, we will print all these values. You see integer 3, double 4.6, boolean is false, and list is equal to brand. So now the point of this is that once you entered here, you would not only print these values out, you would actually use them. You could pass them to some function and use them in the code. For example, your command could be translating your objects, and your double option would simply ask for what distance, and by changing it and then executing the command, that variable would be used. The use of options can be very diverse. You can also use them on their own. You do not actually have to bind them with the getObject class. You could use the getOption class for that. That is why I try to explain how this works in principle, every line of the code. If I just showed you one example, if I invented an example, you actually use the option values to transform an object or something like that, I think that would be very specific and you would understand the example but wouldn't be able to do anything else. And then we didn't achieve anything. But hopefully by doing a generic example like this, I hope you understood how command line options work enough to be able to build on top of it yourself. If you're having trouble with it, I will help you, of course. As I said, you can develop this further, and this is enough for level 1. I will address some more complicated options in higher level courses. Now let's move on to dialogues or forms, my favorite way of user interface. If you have downloaded any of the free plugins I have made for Rhino, and I have made several over the years, you notice that I do not like toolbars that much. I like to work with dialogues or Windows forms, as they're called more commonly in the .NET environment. And forms are powerful, but sometimes they can be hard to handle. That's why in this video I will explain to you how to create two basic types of forms, and we will then learn how to add some buttons and some edit boxes where the user will be able to input some numbers. After that you will be able to deduct from that and realize how all forms work, or you can just wait for the next level course where I will go into describing how sliders work, how values are automatically updated, etc., etc. There are two basic types of forms that interest us: modal and modelless. And you have seen both of them. Modal are the ones when they open, everything else freezes. Try to close your Rhino file. You cannot do anything else until you click one of the buttons. That's a modal dialog. Now go to Analyze Curve. This dialog is hovering there and you can use it if you want to, but you do not have to. That's a modelless dialog, and all my plugins are modelless dialogs. Also notice that I will be using the words form and dialog fairly interchangeably because they're practically the same thing. We're also entering an area where I maybe cannot explain every single variable and every single step. I will explain to you the skeleton of what we will do, and for the rest you can do some research on your own and wait for my higher level courses. With that slight introduction, let's learn by doing. So let us add a new folder to our project, and let us call it forms. So now you can right click on it, and as you can see, when you go to add, you have a Windows form already here. But just in case you do not, and because I want to show you something, click on simply adding a new item like you did for your command, and there is your command at the top. But now you have different options. As you can see, you can create a VPF file, you can create bitmap files, a lot of different type of items. On the left, you can narrow your selection to Windows Forms and create a simple Windows form. You can name it panel gen form, because we will use it for some panel generation. Okay, let's add it. And now you can see the actual form, the actual dialog. And we will see that we can expand this CS file here. So let's minimize this commands folder and open our forms folder. And you can see that you can expand this form file of yours. You will realize that there are several files generated, one with a designer word in it, as you can see here. If you double click the first one, you will see the actual form. If you click the second one, you will see some of the code that follows that form, so you will have the option to change it graphically or control everything from the code if you want to. Of course, a combination of both is optimal. And if you right click on this panel form here, if you right click, you can view the code. That's another part of the code. So you will have double click will get you to the graphical interface. The designer is a part of the code, as you will see. This partial class is a tip for you. In C# you can divide classes in different folders. And this is one part of the code, and pressing the right click and go to view code is the second part of the code, as you can see, of your partial class panel gen form. So once you do that, as you can see, you can graphically resize the form, put it to any size you want, and as you will see later in our properties menu, we can change and add a lot to it. You will see there is some other things here. There is a file called resx, but we will not concern ourselves much with this file because it is a resource file written in XML code. XML is an acronym for Extensible Markup Language, used very extensively in the web design especially, but everywhere else as well. And it is very likable because it's easily readable, human readable, and it's imagined to hold data structures. But as I said, just acknowledge its existence for now. Remember that your form comes with 3 files, the CS one, the designer one, and the XML code one. So let's continue. So in C# you can use a hashtag with the word region and then write a name of your region. You can see it here in your designer. It's exactly what is happening. You can start your region, give it some name, and end it. In that way you will be able to minimize the code. It's a useful tool. And that is how you find this secret code in your panel gen form designer. What you will see here already is the size of your form, of your dialog. If you go back and resize your dialog, these numbers will change. So you realize the interconnection between these two files. You have some scaling settings that are not important for now, and you have the name of your dialog and the name shown on top of the dialog. You will see that in your properties of your dialog, you will have its name, this is this text, and in the designer it's this one, which is the text that's written here that you can change. And there is the name, the actual name of the dialog that will be used later on in code to reference this exact window. I might be annoying some of you that have experience in coding by doing this very slowly, but I do not want to rush and I want you to understand every part of this. So a couple of basic things. So I told you that your file panel gen form can be viewed in 2 different ways. With the right click, we can go to its code. And this is basically what you have. You have 3 files that represent one form. So form is a class as any other class. You can see it's derived from the form class. And in C# you can split a single class in multiple files. Just if you want to separate some properties and methods. It's not a big deal. It's a matter of structure and organization. And this is what they did here. Using the keyword partial, as I mentioned before, so you can see that the class panel gen form is divided between these 2 files, the CS file and the designer file. And you can write code here or here. You could write the code that concerns the actual graphical user interface, like buttons and edit boxes, in the designer file, although they will most of the time be generated automatically for you. And now that you know that we are dealing with one class, you can see that the keyword this refers to the current instance of the class. It is not strictly necessary, I think, but it's used sometimes for different reasons, and I'm not going into that now. Just remember that this means this class or this instance of the class, and just calls the class methods. In our case, methods that belong to our panel gen form class derived from the form class. To be able to work with forms, you will need the toolbox. As you can see it here, I have it next to the properties. If you do not see it, then you have to find it and open it in the view. There it is. You can change some things about your dialog. As I told you, you can change the text of the dialog. So this is whatever is, you can see here on the top. And the name of the dialog, which is relevant for further coding. We will want to show our dialog when we execute a command. So what we will do is create a new command. And let's call it X panel generate form, right? For example, panel generator form, only shorter, a version of it. Now we will have to add some namespaces, but we have to add another system namespace that will be useful here, and it's the system one called Windows Forms appropriately. And let us start with this. Let's create some variable called form, and this will call a new object of the forms panel gen form class. Why did I add forms here? We are in our namespace, but because we created our folder forms here, if you go to our form class, you will see that is put actually inside of a nested namespace starting forms. So when I put forms here, it just refers to the name given by my folder and automatically given by my namespace. You can easily go here and delete this, remain in just PA C#1 namespace. In that case, you would not need this. And we will immediately set some values, and the one we will set is the start position of our dialog, and for the start position we will simply use an enumeration that has a center parent value. So what this will do, this will take the parent window of our Windows, which will be the Rhino application, calculate its center and put our dialog there in the center. Now let's pause here. Usually we created a new object of the class using the normal brackets like this, if you remember. Sometimes empty, sometimes with arguments, parameters. In that way we would call the class constructor. This is another way to instantiate a class. Pretty rarely used, but I don't want to let you wonder what this is. You can instantiate a class by immediately initializing some of its fields or properties using the so-called object initialized syntax. For that you can use the curly brackets and immediately set a property. Start position is a property of our class without actually invoking the constructor. The property is called start position and it holds the position of your screen. As I told you, it's just the enumeration that centers it on the parent. You can see it here, for example, if you want to examine that in detail. Now we will simply call the method showDialog to show our dialog, our form, and let us test the command. So for the starters, we will just call showDialog. And let's just test if this works, so we can continue. Test quickly if our X panel gen form works, and as you can see, our dialog opened here. It doesn't do anything at the moment, but we will make it do something. Let's close this and let's go back here for a second. Let us save the result of this method in a variable called form result, and you can see it does return a dialog result enumeration. So this will be a dialog result type. And if I wrote if my form result equals to dialog result enumeration cancel. So here you can see the types of the result my dialog can return. It can tell me if the user aborted, if they click cancel, OK, and so on. So if the user clicked cancel, I can acknowledge that I recognize this and say the dialog closed with the cancel or an X button. At the moment we do not have a cancel button, but we do have X in the corner, and we can return result failure. We will deal with buttons in the next video, but let us add an OK button to our dialog just to show you something. Go to your toolbox, go to your dialog here, to your graphical form. In the toolbox you can expand here all Windows forms, and you can find a button. Simply drag and drop it, and if you go to, with the button selected, if you go to properties, you can, of course, as with the dialog, you can change the text, you can change what it says inside. And if you look under the behavior category, you will see the dialog result property, which is exactly that enumeration. So we can set it to be OK, so we can recognize when the user presses OK. So you can set different buttons that return one of these default dialog result enumeration types. And that's very useful if you want to recognize if the user selected them. So now what we can do is we can go back to our class and we can say else if the result is dialog result OK, then I can copy this code here and says the dialog closed with the OK button, and I will return success, let's say. By the way, you usually do not want for the user to be able to resize your dialog willy-nilly, because that might screw up your buttons and your edit boxes however you position them. So in the appearance here, for the once you select your dialog and go to properties, in the appearance for the form border style, you can set it to be fixed, for example, fixed single, and you can also remove the maximize and minimize box if you want, all the way down. You can see maximize and minimize in your here, and you can do that in your code manually. By the way, you can see that this button of ours, our OK button, appeared here. As I told you, you can do everything in code or graphically. And if I set my minimize box to false and my maximize box to false, and if I go to my designer code, I will see these two new lines appearing here. So you can set everything in code once you're more experienced, or graphically, however you prefer. Just one more thing before we move on. You should connect your form to Rhino. You have to tell it that it is a child of the Rhino window, so that if you minimize Rhino, it goes with it. Right now it might be separated from the Rhino window, so you can actually minimize Rhino and this dialog of yours will remain open, which is not what you want to do. In order to do that, you have to add a reference to the Rhino Windows library. So this is a new thing we're doing now. As you remember from the very beginning of the course, we have the Rhino user interface and Rhino common references that we used. Now we have to add a new one, which is called Rhino Windows, and it will probably not be there by default. So you have to add it. You have to browse. I have it here already. You have to browse here, and you have to go to your program files, and to your Rhino folder and system, and there you will find your Rhino Windows DLL. Where is it? It's here. I will add it now. Now if I go to my command, I will be able to add a Rhino Windows namespace, as you can see here. And once I do that, I can pass to my show dialog, I can actually pass the Rhino Win app main window. This will be a handle to my Rhino, to the main window of my Rhino application, and this will connect my form to it. Now we're done. Let's just test if it works and continue to the next video. As you can see, if I close my dialog with an X, I get a proper message here. If I start my dialog again, if I close it, OK, it says the dialog closed with the OK button. So we can actually test it, and our dialog is modal, which means once it's open, I cannot press anything else here. So we will see in a moment how we can create a modal-less dialog where actually I can use my form and everything else at the same time. Now, this is how you create a modal dialog, a dialog that you have to close in order to do anything else. Before we expand on the dialog, let's see how to create a modal-less one. Okay, we'll continue working on the same dialog and make a modal-less version of it. I don't know if this interests you, but even if it doesn't, I'll tell you. Creating modal-less dialogs in C++ knows to be pretty complicated, and I'm relieved to see that it's fairly easy to do it here, because you basically do not have to change anything in your dialog class. That was it. Now let's continue. So let us create a form property. At the top of our command class, in our panel xpanel gen form command, we can add something like this. We'll set it to be private as a private field, but I will use this shorter syntax. I will define the getter and the setter automatically. So why did I do this? I want to keep track of the state of our dialog. I want to know if it is open or closed. So if it's already open, I don't want to be able to open it again and stuff like that. So if I do this and use this generic get set form, because there is nothing special about get or set that we want to add for now, we can go to our command and check first of all if our form exists, if it's null or not, if the reference, if this variable actually points to something or not. So if null equals panel form, we will do something. So we can comment this reading of the results for now, because it is not important. Let's copy this code here and we will change it a little bit. I will comment this show dialog just to show you the differences here, and instead of creating a new variable, I will use my panel form variable, because this is exactly the type that we need. Again, don't be confused by the forms, it's just a namespace. Because of this additional folder, you can easily get rid of it if you want to. And now I won't give it a starting position. Instead, I'll doing something else. I will use one of its constructors. I will just use its default constructor. My panel form is underlined here because I misspelled it here. Okay, this is it. If our panel form doesn't exist, if it's null, we create a new object. That makes sense. Now, I will write a line and explain what it does. I will say panel form and call its form closed event handler, and I will add another event to it. What happened here? First, we have some weird method called onFormClosed that doesn't exist yet. We're about to create it. But what is this form closed and this weird incremental operator that we usually use to add numbers together? Well, this is the syntax used with event handlers. I cannot go into depth talking about event handlers. I do a bit in my basics lessons. But let me give you the short version. In the Windows programming, you have so-called events. Events make it possible for a class to notify its surroundings when something happens. Your software will listen to those events, and once one of them happens, it can simply handle it. If you hover over the form closed, you can see that it is an event handler. So by using this syntax, you're basically associating the event with your own method. You're telling it that when the form closes, it should call your function. You can explore more on your own and you will learn more in time. Remember that programming is all about experience, but for now you can take this for granted and remember that what you're doing is simply calling your function when the form closes. Notice this, that in this syntax your method's called without the arguments. So let us add that method. You can go to the bottom of your class, of your command class. Run command is just a function. In your command class you can easily add another function. You can actually set it to be private because it will be used just inside here, and you will call it on form closed. And now you will have some standard parameters: object sender, form closed, event arguments E. So again, I beg you to take this more or less for granted, because explaining this in detail will probably only confuse you at this moment. But since I can't help myself, I will just tell you that the first parameter, object, refers to the instance that raises the event, and the second holds the event data. Okay, you can start with this on your own and research if you want. If not, you can just take it for granted for now and use it how it is. We will continue on this in some of the higher level courses. The important thing is that our form closes. When our form closes, we explicitly delete it from the memory. No need to wait for the garbage collector. And we want to dispose of it, as I said, without actually waiting for the garbage collector to do that, and we want to set it to be null once it's closed. And then if we call our command again, after our dialog is closed, a new version of the dialog can be opened. So now what is left to do is only to open the dialog here. I will not save the result at this moment, and I will not call the show dialog. I will call the show method in order to, on our panel form, in order to open the modulus version of it, and I will just pass the main window. Now let's test the command and see what we have. If I execute my panel generate form now, you will see that the dialog is floating, which means now I can actually use the Rhino with the dialog existing here parallelly. This is the model version. If I minimize Rhino, it will minimize my dialog with it. It belongs to it. And if I close my dialog, now OK doesn't do anything, but if I close my dialog and then I re-execute my command, you will see that a new version of my dialog will be open. If I try to execute the command while the dialog is still open, you will see that nothing new happens. I don't create a new one. Why? Because my panel form at that moment is not null. If I execute my command again and again and again, you will see that nothing is happening because we didn't close our dialog, our form, and it is not null. Before we go on, I have to mention that since Rhino 6 there is a new cross-platform way of creating user interfaces, and it's called ETO, E-T-O, or ETO forms. I will not cover them here because for the level we are on, standard forms do much more than a great job, and because in this course we are not discussing cross-platform development. I plan to make a separate small course on cross-platform development. In that course I will definitely cover ETO forms. Next to ETO forms there is a WPF, or Windows Presentation Foundation graphical system. You can Google a bit to see what that is, and what I just said about ETO applies to WPF. I will address it. Some of it will be for free and some will be an integral part of the higher level course. Now let's see how you can expand this form a bit. Add some buttons other than OK and cancel, and as you saw with these messages, we can recognize what buttons are created. Let's say that our new xpanel genForm command generates our facade panels or some type of geometrical panels that we want to create. So let's go to its OK button that at the moment doesn't do anything. We will leave it here, and let's add a button that we will call close. Go to our toolbox with our dialog selected. We add another button here. We go to its properties. Remember, you always have to select the item you want in order to see its properties. These are the properties of the dialog. These are the properties of the button. We can call it close, and we can set its dialog result to cancel. And we can change its name. Name is something that we will use inside the code. We can say b_close. Something more creative than button 1. Here we have with the button, we can say b_OK. Use whatever convention you want. So now let's double click on that button. If we double click on close, you will see it will create an event with the same arguments that we had, the sender and the event arguments. And this is the event that gets handled when you click on the button. If you do not like the name of your event, in this case it's b_close_click, you can actually rename it to whatever you want. Let's rename it just for the sake of exercise. I can rename it to on close button click, but you have to go to the designer file and change the name there as well. So this is our designer file, and you can see that this is our new b_close button. This is its name, this is its text, and this is the event handler. So now I have to call it on close button click, however I named it here, because this is the method that will be called once our button is clicked. Now we should execute some code here, and this button is not really of our concern, and we only want it to close the dialog. So close the instance of this object, of this class, and close it. There is more to say about this, but we will have to leave it for later. So you can test if this works. It should. And if it does, the cool thing is that once the dialog closes, the event form closed occurs, and our onForm closed function gets called in any way our dialog is closed. If you do not believe me, you can add something like a right line here, and you can say form closed. As I told you, probably already I use form and dialog interchangeably. Form is a term more used in the .NET environment, dialog a bit more in the C++, but they are all Windows, and for me it doesn't matter which word you use. Anyway, you can write this and be sure that whenever your form closes in any way, this function is called, and this will be written. I will comment it out for now. Now you can drag another button, and let me do some design here. I actually do not want to have this OK button anymore. It's not important. All I want is to close my dialog, and I will resize it here a bit, make this bigger. And now in my dialog I will drag a new button. I will give it a text that says generate panels horizontally, let's say, and give it a name for my coding, that's b_ for button generate panels horizontally. And you can see that every component has a lot of parameters that you can set, and you can experiment with them. You can disable the button, you can change it visually, and a lot of other things that are usually not important but can help you customize the hell out of it. Now let's create another button. You can copy paste it, and we can call this one generate panels vertically. I'm using shortcuts here, b_ generate panels vertically. Notice that the position and the size of the buttons, they're all tracked in your designer code, and you can change all of that in the code as well as in the graphic editor. So if you're wondering, for example, if the two buttons have the same size or if they're aligned, you can check it there, but not only in your code, you can check it here as well. If I resize my button, you see that these numbers here change, and if I change its position, you can see that its position here changes. Anyway, now let's make another button that will be useful for us because we want to create different types of panelizations. And for this specific button, we will just call it Panelize in 2D and give it some logical name, for example, B Panels 2D. Okay, now again, we can handle the action of clicking on the button by double-clicking on each of these buttons to handle the event. So you can double-click on each one of them and it will create an event in your panel genform CS file. Again, if you want, you can change the name of these classes. I won't do it for now. You have to remember just to connect them in your designer with the proper event handler. I will leave the names as they are. So let's continue with some other aspects of our dialog. Now, as you realize, we will use this dialog to do some panelization, and we will be able to use some of the code we have written before in the panel generator. But before we do that, let's see how edit boxes work or input boxes work so that the user can input some data through them. Now that we imagine that our form helps us generate some facade panels, either horizontally or vertically or in 2 dimensions, let's add some variables that the user can set themselves. Now in C++ we had something that's called edit box, and the equivalent one in .NET environment would be text box, as far as I can realize. So let's drag one into the dialog. Let's say here. And as the name says, this box can contain anything that the user inputs, and if you want it to be a number, then you have to control that manually. So right now it can be any type of text, and in case we want a simple number of panels, horizontally or vertically, we will actually use something more appropriate that .NET has prepared for us, and it is the numeric up-down box, which fits perfectly to our needs. But do not worry, all these components work very similarly, so once you learn how to use one or two of them, like you will now, you can intuitively figure out the rest, because the principles are the same. So let's drag 2 numeric boxes, or let's copy paste this one. And now let's put some static text that explains what they are. In .NET they are called labels. So I will simply put one label here and say number of panels. In its text I will say number of panels horizontally, and put another label here that's called number of panels vertically. Now we want to be able to control our numeric input somehow. We want to be able to read them and maybe input some values. So the first step is to identify them. And for that we use their name. So we click on the component, as we have learned. We will go to their name and we can change it to number of panels horizontally. Remember, we called our buttons the same way here, but we added the B underscore, so that will help us differ between them, and we call this number of panels vertically. That is how we will identify them. And remember what we talked about before, everything you change in the dialog is followed by code in your designer. So if you go there and you can see the name of our component, the size and the tab index and everything. If you are wondering what the tab index is, the tab index simply determines the order in which the focus will change when the user presses the tab button among the components inside your dialog. So you can change all of this from the code or from the design. You can see all of your components have this tab index, and the ones they don't, you can add it to them. First thing you will want to do is determine the minimum and the maximum number the user can set. Again, you can do this in the code, but also in the properties. So if you click on one of them, you go to the data, you can see here the maximum and minimum. So let's change it and leave it from 0, or let's say the minimum is 1 and the maximum is 20. You can do this for both of them if you want. Let's say we want from 1 to 20. And if you go to your designer, you will see that this already changed. It added some new code to your number panels vertical and number horizontal component. You see you have little arrows for incrementation here, and the increment can stay 1. If you want your increment to be larger, you can do it. You can set it 5, then it will be 5, 10, 15, and so on. Or in this case, 1, 6, 11, and so on. If you examine this a little bit, you will see that you can change the font if you want, the foreground color, the background color, and all other stuff. But we are not concerned with design at this moment, so you can play with that yourself as much as you would like. What we would like to know is how to set a certain value and how to retrieve it. First, we will set the default value, but where? So, well, right there in your initialize component function. By the way, this is the initialize component function that does all the initializations. You can just find your components. Here is our panel horizontal, here's our panels verticals, and you can add something like this. So let's do this in code. You can say this, numbers of panels horizontal is what we're dealing here, and you can access its value and give it some default value of, let's say, 15 panels horizontal. You can do the same here. This number of panels vertical value and give it some value of, let's say, 20. And if you go back to your graphic editor, you will see that the value here has changed to 20 and the value here has changed to 15. You cannot put decimal numbers because for decimal places you put 0, and that's exactly what we want. We do not want decimal, we do not want double precision, we want integer numbers. But in the case you want double precision numbers, you can set the increment here to 0.1 or whatever. You can set the number of decimal places. You can play with it however you want. Now let's see how to read the current values from this numeric input, or how is it called? It's called numeric up-down, exactly. So let's see how to read values from this numeric up-down component. Once we click on our panels 2D, it will bring us back to our event handler, and we can say something like this, just for test for purposes. String text equals to string format. You have this many horizontal panels and this many vertical panels. And now we will simply access our component over its name and access its value and just convert it to string. And we will do the same thing with our vertical component, vertical numeric up down, access its value and convert it to string. Very easily. Notice that the form class, of course, you do not want to forget to actually write this line, so you can see it in your Rhino. And our gen form doesn't have any Rhino classes, as I can see here, so we will need to add some. Let's see if using Rhino is good for now. For now it's good, because we just want to write line and we want to write this text. Now let's test this to see if it works, because we've done a lot. So if I start my xpanel gen form, now it has this that you saw. You see we can increment our numbers, we can write them down by hand, and once I press panelize 2D, it will actually read the values that are here. As you can see, 13 and 20. I can repeat this. I cannot go over 20 because I put the maximum at 20. That's why when I put 45, it just brought me back to 20. If I put 7, it will remain 7. Panelize 13 and 7. And we can close our dialog. And we can reopen our dialog. And if we try to reopen it while it's open, it won't work because it already exists. So our dialog functions pretty well. So let's continue using it. I will not expand more on the dialogues. I could make an entire course only on the model and modelless dialogue application. That's why I need you to invest some time in exploring. I will be there to help you, and if you're struggling, I will gladly make additional explanation videos if I see you struggling. And I have to divide the material through different levels, and I think that what I showed you belongs to the level of programming that you're learning in this course. And after we covered some more advanced themes in the second level, you will be able to handle more complicated dialogue interaction, including the handling of complex modeless dialogues. We will talk about parametrics now a bit, and we will create a function that generates panels for us. And at the end, I might end up showing you one or two more components for the dialogue. So let's go. We will not learn anything new about forms here, but I separated this video because here we will create our functions that generate the panels horizontally, vertically, or in two directions. And I hope that this will be interesting for you because you will pick up on some small details of how to create something like this from scratch. And if you understand everything, and I will make sure you do, then you are already equipped to do some pretty complex algorithms. Now, I said I will generate different functions, but if you think about it, that doesn't make much sense. A function that generates panels in one or two directions does a lot of the same thing. Only some small thing like a vector would change. So let's create one single function in our useful functions. Go back there and let's call it, all the way at the bottom, let's call it panel generator. It will be static. Let's put it void for now, and let's call it, let's edit the X like we used to, X panel generator. Or let's give it a Boolean variable so that we can know if it was executed successfully or not. We will return false by default. Okay, now let's think what we need to pass to the function. If you go to our X generate panels command, which was here, you will remember what we did there. There we prompted the user to select exactly 4 points. We could do that again in this case. So what we want to pass as an argument is a point 3D list, as you can see here. If you look at our command, you will see that that was enough to create panels. We could pass the names of the layers separately, but I will not do that. I will leave that to you to do as an exercise. I will simply determine the name of the layer inside our new function, and instead I will want to know if I'm generating panels horizontally or vertically or both. Well, usually if you are working with some more complicated forms, you can set some integer value that will hold, let's say 0 if the panel is horizontal, 1 if it's vertical, 2 if it's in 2 dimension, or you can even create your own enumeration. Let's call it panel direction, and you can give it some values as horizontal, vertical, both ways, or something like that. If you did that, afterwards you could simply use this enumeration to access its values. And then in your run command functions later you can simply access this, you could pass that, and again I will leave this to you as an exercise. You have to do some things on your own. I will choose the third option. I will put some Boolean variables inside our function, as you will see, and that one will just simply tell us if we are moving horizontally or vertically, and one that will tell us how many panels we are generating. This is what we will do, as I just promised. We will go to our new useful function that's called the X panel generator. We will pass it some point 3D list called corner points. Then we can pass some Boolean variable that's called b_dir horizontal, and I can add a comment here. I can say true means our panels will be generated horizontally, false means our panels will be generated vertically. And what I can pass is the number of panels to generate. This will be a simple integer value, number of panels. Okay, now we have everything we need to generate some panels in one direction. If not, we can add stuff later. Now, before we start writing the code, I suggest we check if we passed everything correctly. So go to one of our buttons and add the code that prompts the user to select the points. So let's go to our generate panels horizontally, for example. And we can prompt the user to select the points. Of course, we will need a point 3D list and some other Rhino functions, some other Rhino user spaces, some other Rhino namespaces. Just go to one of your commands and copy all of them. Or if you want to be meticulous, just copy the ones you need. In our case, right now, we only need collection, so we can recognize our point 3D list. So we will have a point 3D list of new corner points, instantiated, and then we will simply call our useful functions and our xSelectPoints method, tell the user to select exactly 4 points for the facade panel, and inside this function we will get our list filled. We will simply check if we have exactly 4 corner points, otherwise we will not want to continue with the function, and that's it. So you notice that we had to add the namespaces to the top of the document. Now your function is void at this moment. What you will realize now is that what we should do is basically copy this code to all 3 button events, because whatever the user presses here, we want them to select the 4 points first. This seems a bit stupid. What I would do maybe is create a 4th button that is used only to select points, and then all these buttons will simply check if the points are already selected or not. Well, as you can guess, there are 100 different ways to do this, and I chose this one, and I will let you experiment with others. So let us do this. Let's copy the same code to all 3 of our buttons. This text is not important anymore. You can delete it, comment it out, however you want. What's important that whatever we press, the user selects exactly 4 points. We can actually cut this, we can actually copy this inside a useful function to see if everything worked there. We can say you have this many panels in a row, because at this moment we're not sure if we are generating them horizontally or vertically, and we can just invoke this value here and write it as a string. As you will see in a minute, that makes sense if it doesn't now. So, okay, now let's call our function. Let's go again. If you have trouble finding your method, you can simply go to your form, double click on it, and you can just use the useful function class to call its static method called xPanelGenerator. We will pass it the new corner points that the user just selected. We will pass true because we want to generate them horizontally. Now we're in this horizontal click event, and what we want to pass is the number of panels. Now if you remember, number of panels horizontal, that's what we want to pass in this horizontal event, and we want to pass its value. However, this value, as you can see, is a decimal type. It's a number, and we really want to pass an integer. In order to pass this number as an integer safely, I recommend to use something that belongs to the .NET framework. It's a decimal structure, and you can call its toInt32 method, or to some other type of integer that you want, and simply cast this value to be a proper integer. And we will have to close our method. Okay, so now let's copy some code from our panel command in order to actually generate panels, because our useful function is still empty except for writing this text. So if you go to our xPanelGenerator, xGeneratePanels we called it, the command where we used to generate a whole row of panels. If you remember, we can copy the code and change it. As I told you, what we will very often do is the copy entire chunks of code and then change them. Let's do that here as well. Just simply copy everything here after we check the count, and then we will able to delete what we do not need. Okay, so let's see what changes we have to make. Let's change this parameter to be called initial corner points, and then inside here we will make our point 3D list, a new one that's called corner points, and we will initialize it using the input corner points. Then you saw that we used some random stuff here. We can copy this here. We will not use the repetitions because now we have that passed as a number of panels. We can leave this parent layer here with the X, and as you can see here, what we are missing is our Rhino document. So we obviously have to pass our Rhino document to our function as well. So let's do that. We already did that many times. Rhino doc, and wherever we are calling this function, here we will actually have to pass the doc. Now we are retracing our steps. We are passing the document here, but we do not have it in our panel form. That's interesting. So let's edit somehow. Let's pass the Rhino document to our dialog. Now, how to pass the document to it? There are different ways of doing this, but let's choose one that is not confusing. Let's add a private Rhino doc variable in our form. At the top of our form, we can simply add a private Rhino doc form field. And we want it to point to the same Rhino document that we are using at the moment. And we can set that immediately in the class constructor. So our class constructor is right here. All it is doing now is calling this initialize component method that initializes all the components inside the dialog, and it is called whenever our dialog is created. So what we want to do is simply point our doc form to the document, and what we need to pass is the actual document. And as I have told you before, every constructor can actually have parameters. You can have multiple overloads. For now, we will just use this one. This means, however, that whenever our panel is generated, and if you remember, it is generated in our x panel gen form command, right here, it's underlined because now we actually have to pass it the document. And now everything should work. We are inside our command. We are passing the document to our newly generated form, to its constructor. Its constructor is here. We'll use its private Rhino doc field to point to our document, and then inside our function, once we call the xPanel generator, we can pass this doc form. And once we are inside our useful function, right click, go to definition, we will actually have a document here in order to set our layers. Now let's change the other stuff quickly. The number of repetition disappeared, but that is why we have the number of panels. It's a number of panels that we are going to generate. We will create a new panel. It is not recognized here. Why? Well, we did not add the namespace of our using panels. So we will add our PA C#1 classes namespace, because that is where our panel is defined. And now our panel is recognized. We will create its corner points using these corner points. If all this is very confusing, pause the video anytime you want. You have the code, you can examine it. It's all more or less logical, you just have to get used to it. Our corner points have a bounding box, center, this is okay. We are inside the useful functions right now, so you don't actually have to call useful functions. You can just call your setLayer function method. And as you can see, as I see now, I made it without an X, so you can keep your convention if you want. And we have our transformations that now work with corner points. It's not called new corner points anymore, so you have to exchange that everywhere. Now this function should work. Again, useful function not needed, and we will going to test it in the next video. Just wanted to tell you a little thing about this Rhino document. We are now passing the actual document to the dialog, but very often you will not want to do that. You will just simply have some values that you will have set in the dialog. You will retrieve those values in your command or somewhere else, and then you will actually draw stuff. This is a slightly more complicated version that I think you should know, and you should learn how to pass the Rhino document to the dialog or to wherever else you want in order to be able to use it inside. So let's continue to the next video and see how our function can be used. So in the last video we took the code from our old xGeneratePanels command. We copy pasted it into this panel generator useful function that we made that looks like this right now, and we changed some things. We changed this init corner points variable to be called init corner points, and we used it to initialize our corner points inside. And then afterwards we used this variable in order to generate the panels. As you remember, just shortly we created a parent layer, then we entered a loop. In our case, the number of panels will determine the size of the loop. And then we have the same code as before. We create a new panel, call it setCornerPoints method that we created, set.name property, and then we called our rebuild method, and we draw stuff in different layers. And then of course, as you remember, we did some translation and rotation in order to create a whole row of elements. And if you remember how translation worked, it worked by translating the panel from point 0 to point 1. And that is what kind of determined the horizontal direction, because we created our horizontal row with our panels. If you don't remember, just go back, open Rhino and execute your xGeneratePanels function and select 4 points in the right order. If you draw points or select points in a different order, then that would change and it would not work how we imagined it. But we will leave that for now, just not to complicate the example. And you be sure that whenever you draw points, you draw them in the front view in the right order. So now what we will do is change our function to work in both directions, horizontal and vertical. How are we going to do that? But let's think what's the main difference. First, the panel is generated, that is the same, but then the panel is translated using the vector that goes from point 1 to point 0, as we said. And this is what we determined to be horizontal. Then if we want a vertical translation, we just have to translate from point 1 to point 2, right? And here is where our bool argument will come into play. What we can do is we can change our translation in the following way. We can first instantiate it. We can say transform xform is the new object of the transform structure. And then if our dir horizontal boolean is true, which means we are generating panels horizontally, then our xform becomes this translation. If it's not, if we are generating panels vertically, then we will simply translate them from point 1 to point 2, which in our case will be vertical. And then we will simply transform our points. Now, how about rotation? Our random rotation is happening around the point 0, and since we do not specify any rotation axis, it rotates in our construction plane around the z-axis. If we did the same with the vertical paneling, our panels would not be connected anymore, and we would like to rotate our panels around a different axis. Which one? Well, I would say around the axis that goes along the upper edge. And you know what? In the horizontal panelization, it makes sense to actually rotate around the side edge. So let us change the rotation axis for both cases. We will create our random number, which remains the same, but now we will create a simple 3D vector, and we'll call it rotation axis vector. If we are generating panels horizontally, let our rotation axis vector be a new vector, 3D, that goes from corner points 3 that finishes at corner points 3 and start at corner point 0. As you remember, you always subtract from the last point when you're creating a vector. Use the vertical edge as a rotation axis. If we're generating panels vertically, then we will use a horizontal edge as a rotational axis. And this remains the same, except that now we will use a different rotation method, a different overload, the one that actually takes the rotation axis into consideration as well. Yeah, I hope you understand what's happening here. If not, pause the video and think about how the panels are generated. Each panel is a copy of the previous one, and then translated and then rotated around one of its edges. Now go to our button event for vertical panel. Again, you can go to your form, go to your vertical panel event, and call the useful function, our function that generates panels. But now we want to pass false here because it's vertical, and we want to pass the number of panels in vertical direction, which is called number panels vertical, which will simply read this number here and pass it, if you remember. And let's try the code. I will start the panel form, and let's generate panels horizontally, 0, 1, 2, 3, and enter. And as you can see, I generated the panels as we did before. Now I can select, right click on this parent layer here and say select all sub-layer objects and delete them. And let me create, and as you saw, there were 15 panels. You can try again with 7, 8, or whatever number you want. Now let's generate the panels vertically, again 0, 1, 2, 3, and now as you can see, our panels are generated vertically, and we generated 20 different panels from 0 to 19. So this works. Let's now tackle the 2D generation. Let's think. The easiest thing we could do is take one direction, let's say the horizontal one, put it inside the loop, and do it the number of times that is defined by the user in the dialog for vertical generation. And every time, after every horizontal row, we would just translate our points vertically. So let's do that and see what happens. So now let's go to our form. Let's click on Panelize 2D. And what we want to do is we want to define our vector using the initial 4 points. Remember that those 4 points get translated inside our useful function. So we want to create our vector at the beginning before these points are translated, before all that happens. And then we will do the transformation after each iteration, after each row is generated. So I will create a new transformation here, a translation one, that will follow a vector that goes from new corner points 0 to new corner points 3. It's simply a vertical vector. What I can do now is I can enter a loop. As we said, a loop that has the size of the number of panels vertical. But if we are in a loop, we really want to have an integer value, not a decimal value. So we will again use that trick that I told you, decimal to int 32, in order to cast this value into a proper integer. And we will iterate through it. And what we will do inside every iteration, well, inside every iteration, we will simply call our useful function to generate a horizontal row. So we are simply generating horizontal rows one by one, but every time we do generate one, we transform our new corner points. We simply translate them vertically, as we have defined here. For the transform, you will need the geometry space, but I already put it here. So new corner points will be picked by the user. They will enter this horizontal function, create a horizontal row. They will be shifted vertically and then create another horizontal row, and so on and so on. So let's test how this works. Xpanel gen form, and now we want to generate in 2D. We will select 0, 1, 2, 3, and you will see that the panels are generated row by row, one by one. I will have to wait until they're all generated to show them to you. Here they are. I can here hide our panel names, and I can see my panelization here. It's fairly random because we're always rotating the panels. So what we did, again, we went for 20 vertical rows, and in each row we created 15 panels. Of course, again, you can do the same thing as before. You can select all the sublayer objects, delete them, try with some other number, let's say 7, 7, and see that it works. And notice that we are redrawing the views too much. You see how slow this is? It's very slow. This should kind of work instantaneously. So if you check your useful functions, you will see that you are redrawing every panel as it is being built. You can see here. So now what we will do is we will close our debugging Rhino. We can simply delete this or comment this out. And you can move this either to the outside of your loop here, or in the case of the 2D panel generation, you can simply redraw when everything is done. Of course, don't forget that we inside our panel form, we have a doc form variable, not a doc. So you can test this. I will speed this up. And I press enter now. You will see that it goes much faster because I'm redrawing only at the end. Now this looks cool. Check the top view, turn on the rendered view, or the artistic view, or even better, turn on the environment map. But it would be cooler if the panels were somehow connected. Well, in that case, it's much better to work with point matrices and not panels directly. You would have to create a two-dimensional array of points and then generate panels between them. But I will leave it to you to test something like that and get back to me. I will also create some more specific courses that deal with panelization later. And if you have problems with it, I will maybe think of creating a small separate course that will deal only with panelization methods. This is a level 1 course intended to teach you the foundations of Rhino programming, and it makes no sense to dwell on specific applications. Maybe you're an industrial designer and you do not care about facade panelization, and panelization can be a relatively big and complex subject with a lot to learn. So let's leave those specific cases for some other courses. It's hard to imagine all different ways in which you will want to use programming. So I tried to create this a bit abstract problem in order to show you some fundamentals and cover different things along the way. You learned a bit about passing by reference along the interaction with the form. I want you to experiment with different dialog components as well. You saw how easy it was with the numeric component. But let's continue. So let's say that I want to add a checkbox. I can go here, push my buttons a little bit down, select my dialog, go to my toolbox, and add a little checkbox here. And let's say that if I go to properties for my checkbox, this will determine if I will actually draw the text dots of the panels or not. Its name, could it be check draw dots? Let's keep it clear with an underscore. Again, I'm not using any specific convention here, but you're free to develop one of your own. If you go to the appearance, you will see that it has a default state, which is now false. If you want it checked by default, you can simply set this to true. And of course, you can track in your code what is happening when you do that. And how to handle this? Well, it's very, very intuitive. If you go to one of your events, you can double click on the button. And what you could do, for example, here, you could simply create one Boolean variable, call it however you want. You can then call your checkbox name that you created, in our case is C_draw_dots, and you can call on its value, on its property. The property is called checked, and of course it will return false if it's unchecked, true if it's checked. Once you do that, I would suggest that you, as an exercise, take our xpanel generator function, you add a new parameter to it, which is a Boolean type. You will pass this s wherever you want. You can do it at the end of the function. Once you do make your new parameter, let's say, imagine you created it here, and it says draw dots. Imagine you made it here. I will delete it for now. I will leave that to you. And then in theory, you could go here and you can say, if this is true, then I will put all of this inside the curly bracket. So I want to draw my dots only if the user checked the checkbox. So this is an example of a nice little exercise of how you can use the checkboxes. And as I told you before, this is the template for all different kinds of tools you can use here. You can drag them, whatever you need, different sliders, scrolls, images. You will define their name, and by using their name, you will be able to access their methods. And if you hover over them, you will see the type, the class they belong to, in this case checkbox, and you can go online and find that particular type, the particular class. You can just Google C# checkbox, .NET checkbox, and you will be able to see what methods you can use, what properties they have. It's very intuitive. It's in the same way that we are using this Rhino help file of ours. Okay, so let us continue. To finish up this section about user interface, I will just show you how you can use command prompt, and this will probably be the shortest video in this entire course. So sometimes when you have iterative algorithms, you want to see in the command prompt your progress. In our case, we would like to see, let's say, the progress of our panels being generated. So you could go to our useful function, our panel generator, just for the test purposes, and inside our loop, you could write something like this. You would access your Rhino application in the same way that you access it to write a line. This time you will access it to set the command prompt. And you can simply format a string to say panel, this particular panel is being generated whatever you want to draw, and for the panel you will just put your current iteration by casting it to string. And at the very end, when you generated everything, or everything is done, when you're outside the loop, you can simply send your command prompt to be null. There is one more thing you have to do, and I'll explain in a second why. You will add the wait function. You will call the wait method. Now, let's test this just for a second to see how it works, and then I will tell you how maybe you can change this and what is what. I will call our panel gen form. I will leave it to have 15 horizontal panels and 20 rows. I will generate in 2D. And now keep an eye on this command line prompt. It will be probably very fast. You see that it's changing and it's telling you which panels is getting generated. And of course, this is a write line that you have somewhere in your code that you can check and delete. It's this one here. You have this many panels in a row, so you can delete that one for our test purposes. We do not need to write it. And as you saw, our panel goes only from 0 to 15, because we are inside of this here loop. What you would want to do this probably, you could go and update the command prompt. You could update the command prompt inside of this big loop, where you can track the horizontal panels, and then you would update them for very row, which probably makes more sense in this case, because this is way too fast for you to see the updates. And as far as the Rhino app wait function goes, I will not go into the reasons why you have to call it. I mean, I don't understand it 100% either, but you should put this in the code, because in that case your code will pause for a very short amount of time, enabling Windows messages to work properly, to catch up. And if you don't put it, you might get into trouble. Also, my experience shows that updating your command prompt will slow down your process a little bit. So if you're doing something that has lots of iterations, I did lots of statistical calculations that have thousands of millions of iterations, my advice is not to update it all the time, maybe just from time to time. And in our case, as I said, it would probably be ideal if we put our command prompt right here inside of our big loop. And if we moved this Rhino command prompt here also, cut it and paste it here to the end. In this case, it would be updated only for each row of the panel. You could change this to row. And I will redraw now every single row so that we slow down the process a little bit, just so we can see the command prompt being updated. I will start my command, select my points, zoom out a little bit, and keep an eye here. You will see you saw very fastly how the rows are generated, but you get the gist of it. With this, we're almost done with our level 1 course. Let's go to the final section, where I will try to sum up what we did and what we didn't do, and talk about how to go on from here.